Awesome. So thank you guys for hanging out. Like I said, hope you had a good long weekend. I put a plan up on Canvas for this week and kind of an idea for what I think might happen next week with the return to hybrid, I think, next week. From what we've heard, it's happening. And I think, everything is tentative at this point in our lives, but from what we know, we'll be back to the hybrid schedule that we were in before Thanksgiving. I don't think anything changes about what cohort you're in or the schedule that goes with it. Monday is cohort A, Tuesday cohort B, Wednesday back to A, Thursday back to B, and then Friday everybody's home and doing things from home. So I tried to give us at least this week and next week kind of planned out. So if you go to today's announcement, because that's where everything is that you will need for today, you can see that I tried to give you a heads up as to what I was thinking. I know it's been a lot with us trying to play a lot of catch up. We've been going a lot like every day. And I'm sure that there are a lot of your classes that might be doing that. And so what I wanted to give you over the next couple days was a little time off from these Google Meets and give you time to work on your own if that's what you'd like. We're done with chapter 4, and so we're going to take our test on Thursday. It's going to be open notes. You have everything in front of you, and I don't think it's going to take very long. It'll just be a couple things from 4.5, and then some things from 4.6, and some things from 4.7, which are simple and pretty straightforward once you get it. But what I saw on your responses from Fridays, I think it was Friday, I sent out that Google form just to kind of give you a chance to let me know how you were doing, is that some people were feeling better about some things and some people were still struggling with other things. So, and so what I tried to do was give us enough time between today and tomorrow to get ready. Giving you the freedom to say, you know what, I'm good, I've got it. I know I have other things going on, and I'll be fine for Thursday's test if I just review my notes and go through a little extra practice. Or you say, you know what, I really need to hear that whole 4.7 thing again, or I really need to see some graphs from 4.6 again, or man, I'm still struggling with sinusoids from 4.5, I want some extra help. That would be the time to ask those kind of questions. So here's the deal. Test Thursday, okay? I will send out a link to the Google form where you will do, where you find the questions. I'll send that out, right before the test, kind of like I did for the final where you got an email like a minute before class started. I'll do that again. You'll just sit on the Google Meet in case something comes up. You can ask questions, or I can just see you working and make sure that everything's going okay. And then you'll just submit pictures of any problems that require work, like graphing some of these things by hand, or finding the period, or whatever it is, writing the equations down. Whatever I can't do via Google Form, I'll just have you submit pictures to the assignment that's created on Canvas. So what I wanted to do today and tomorrow, with whatever time we've got, is give you a chance to practice, to give us a chance to see things again, or to have me reteach something. I know I went through some stuff pretty quickly on Thursday, and I want to slow it down and make sure you're feeling confident. Because the first test is always a good one to do well on, because that's going to carry so much weight in your grade until we get to the next one. So I put a review on Canvas. So if you click on that, open that up, it's probably one of the first links that are sitting there. Yeah, so it says plan for this week, Tuesday, and then it's got review 4.5 through 4.7. That's got all the practice questions on there. And you'll see, what I'm expecting from each of those 3 sections. And then I attached the notes from the 3 sections. Basically, the 4.5 stuff was the pictures that I took of the board when I wrote down how to do both things. Here's a equation, graph it, or here's a graph, come up with the equation for 4.5. And then the wrap up for 4.6 and 4.7, where I tried to kind of break some stuff down. How did we come up with the tangent graph? How did we come up with cotangent and cosecant and secant? And what's the domain? What's the range? what are the periods for all of those. And then the 4.7 stuff with all the inverse trig stuff, all of the arc sine, arc cosine, arc tangent. I tried to write some stuff down. So that's all sitting there next to the Tuesday, that's today, plan for this week, okay? Tomorrow is registration day. And the schedule for tomorrow is just a little bit different because they're going to drop homeroom from between the 4th and 5th period, and they kind of front-loaded it as a kind of an opening informational video time that counseling put together. So if you have a first period class, you will go to that. If you don't have a first period class, you'll come to me just during that time, just so I can share that video with you. So you know what the day is going to look like. And in our case, what we'll do on Wednesday is it'll just kind of be another day to practice, a day to wrap up and review. Whatever you don't do today, you can finish up tomorrow to get you ready for Thursday. And what I'll do is I will break us into individual breakout rooms so I can have one-on-one conversations with you, just to make sure that the selection that you've made is still the one you want to do, and then I can just kind of confirm that. And then you'll do your registration on your own. I just want to make sure that I have written down what you're going to sign up for and kind of answer any last minute questions that you might have on that. Okay. Thursday will be our test. Open notes. It's all good. I want you to be able to look at that stuff and say, okay, how do I find the starting point? How do I find the ending point? How do I find the 3 points in between? How do I, so a graph for inverse cosine, whatever. I don't mind you looking at that stuff because the reality is we did it really quickly, and I would much rather you just do well on this test. And if you can look at your notes and interpret them to be able to solve some of these, answer some of these questions, then you're great and you've got it. That's all I really care about. And then we can move on. Okay, and so I'd like to move on Friday because this is a shorter week. I really don't want to miss out on taking Friday to get started working with formulas and identities in chapter 5. So that trig cheat sheet that I sent out is going to be super, super helpful. We're not going to memorize any of that stuff. We're just going to know how to find them on that cheat sheet and how to use them. And I don't want to spend a ton of time. Actually, chapter 5 is relatively short in terms of what we want to accomplish, and then we'll start calculus. Now, so when we get back to hybrid next week, we'll still be in chapter 5. We'll still have some trig stuff to do, but I'm hoping that it's just that week. I just want to really just spend the week working with a couple different formulas and identities. And so on your at-home days, you'll log on live. Of course, when you're here, you'll log on so that I'm not wasting. I'm not wasting a lot of time doing things twice, right? Formulas and identities are really things you want to see in person, kind of walk through with me, because they'll be a little bit different. We haven't done stuff like that. But once you get it, oh, okay, then I just plug it into the formula and I let the trigs take care of itself. Yeah, so that'll be good. So that's my plan. That's what I'm thinking for these next couple of weeks. Today, review. Tomorrow, individual breakout rooms with registration confirmation stuff and finishing up the review. Thursday, test, which you'll receive a link to a Google form right before the start of class. And then anything that you have to handwrite, like you're going to draw some graphs, things like that, you just take pictures of and upload it to kind of supplement whatever we do on that Google form. Plenty of multiple choice stuff, maybe some fill in the blanks, maybe some check boxes, where you can select more than one correct answer, stuff like that. And then Friday we'll start chapter 5, so we'll log on just like you guys are right now, one last time all together. And then starting next week, we'll be back to the hybrid the way it looks right now, unless numbers drastically change one way or the other. That's kind of what the plan looks like. So questions on that? Now I can look down at you guys sitting down there. All good? Cool, sweet. So here is the time where you can say, you know what, I'm going to do my thing. I'm not going to stick around this Google Meet. I'm going to head out and I will see you guys tomorrow. But for anybody that wants to stick around and has some specific questions that they think maybe a lot of people might benefit from hearing the answers to, go for it. the thing that I'll leave you with is that I am going to work through the solutions to the review today, try to get it up there tonight or first thing tomorrow, so that you can kind of go forward with confidence that what you've done looks good. Okay, so if you're sticking around, awesome, stick around. If you are headed out, I will see you tomorrow, same time. Actually, no, timing's a little bit different, right? Check the schedule on. I'll put a copy of the schedule up on Canvas so you guys can check it out, but I'm sure it's on phsmustangs.com too if you want to check that out before I do that. Okay, so stick around if you'd like. Otherwise, have a great day. Thank you for dropping in, and I will see you tomorrow. Awesome. So, questions. What do you want to see? Is there anything I can help you with? 4.6, 4.7, I guess, is probably where most of our questions are. But if there's something from 4.5 you want to see, I'm happy to help. What do you got?
For me, it would be good if you could just show an example of one where you already have the graph and you find the equation from the graph.
Sure. Okay. All right, so let me make one up. Let's see. And so what you're going to see on the review, and it's just good to be comfortable doing, is that when we're looking at sine and cosine transformations, I can find a sine equation and I can find a cosine equation, right? And everything is the same except for the starting point. Amplitude is going to be the same, frequency is the same, midline's the same, right? All that stuff is the same. It's just that phase shift that we want to keep an eye on. And so when I do this one, and when you work on ones on the review, you can see that when I get to that section of 4.5, I ask you to find both. Like find a sine equation, find a cosine equation, and you're gonna like A is the same, B is the same, and D is the same. It's really just the C over B because of where we start. Okay, and so if I'm trying to find a sine equation, y equals a sine of b of theta minus c over b, two parentheses, plus d. Like all of that except for b is gonna c over b is gonna be the same. And of course, I'll just change the sine to cosine. But we'll start with the sine one. And what I know about sine is that sine starts on the midline and goes up. And so that's what I kind of think about looking for first. Because if I can figure out where to start, then I'll figure out like, okay, how long does it take me to get to the end? How far does it get me to get from the top to the bottom? And I can really just start kind of piecing all of those things together to figure out, okay, what's A, what's B, what's C over B, and what's D. And usually what I try to do when looking for that starting point is to kind of either visually or actually like drawing in where the midline might be, right? Where is the middle of this graph? Do you think you can do that? Like, can you look at a graph and see where the middle is?
Yeah, and the amplitude too, like I get that part.
Awesome.
I think the phase, or maybe the starting point and the phase shift is what confuses me the most.
So look at my notes that the first set of notes that I attached today, but it was what I wrote up there like a week ago for 4.5. It reminds us of where that starting point might be for sine and for cosine. For a sine graph, it starts at the midline and goes up. That's going to be where my first point is for sine. And I try to just stay near the origin as best I can. I'm going to stick pretty close to the y-axis, and I'll see if I can find a point that starts on the midline, and then from left to right that the graph goes up, because that's kind of like the regular flow of sine. And if you look at the review that I posted for the day, like the very first thing I ask you to do is like, can you just graph sine? Can you just graph like plain old sine and cosine? Because if you can do that, then you can move forward. If we don't know how to do that, then we're in a little bit of trouble. Because if we know that the graph of sine looks like that, right? Starts at the midline, goes up, comes back down, goes to the bottom, and makes its way back to the midline, then I've got, but really all I need is to be able to visualize or trace one cycle, because then it'll just repeat in any direction that I want. And so can you see kind of like that blue overlay? I don't know if it's close enough there to really see the difference, but like there is a point that starts on the midline and the graph goes up. And so for me right there, there's my starting point for sine. And so when I try to like create this, okay, I'm gonna leave a space right now for that. I'll leave a space for that. Like theta right there is like minus c over b. Well, I actually found a really good starting point on this graph to be right at 0. And so I've got right now like minus 0. And of course, I'm not going to actually write that when I write the whole thing out, but just so we can see how it works. Now, could I have picked this point over here because it starts in the midline and goes up? Sure. Or this one, or this one? Absolutely. And so you're going to see that there are a lot of possibilities for the phase shift. In other words, like you can pick any starting point that you see that allows you to make it all the way through one full cycle. I just think it's nice to pick numbers near 0 if I can. And so for me, hey, look, nice, 0. Perfect. I like that one. And so I'm going to write it all out this way, but then at the bottom, I'll show you how I'll just simplify it. Obviously, I'm not going to put minus 0 in that. Okay. The midline is right there at 1, right? So plus 1 at the end. Doesn't matter what order you do it in. You can just kind of make it work however you want. A, the distance from the midline to the top, and let's say that, 1, 2, 3, 4. So that distance is 2, so A is 2. Really, the only tricky part now, I think, once I've been able to kind of sketch just that one full cycle, is to figure out what B is. Like, what is the frequency that goes with it? And you can either think about it, or you can use a nice equation and just plug stuff in. So that's kind of up to you. For me, having a formula that I can always rely on will help me when like the phase shift is weird or the frequency is not something that's easily countable with boxes. Like what if my starting point was nice, but my ending point was in the middle of a box somewhere? Or it landed on a spot that I just didn't recognize or something like that. Or, I don't want to, what if I was at a box that didn't have a label or something like that? So what I like to kind of count on is, like, we know that the new period, that omega, was always 2 pi over b. When we first started doing this, we were given equations and we just tried to figure out, okay, how long is it going to take it to make its way through one full cycle, right? And that's what omega was. But now that we're kind of going the other way, now I just want to rearrange this. And this is part of the notes that are there, right? Is that the frequency is 2 pi over whatever the period is for this function. And remember, period is just how long it takes you to make it through one full cycle. And so really what I'm trying to measure is this distance right there, right? How long did it take me to get from my starting point to my ending point? That right there is going to be omega. And so you can either just visualize it and look, or you can look at the notes that I put up there that says, if I can just subtract x values from my ending point and my starting point, that'll give me the distance between them, right? Because imagine all right, I'm going from 2 to 7. How far is the distance between 2 and 7? Oh, it's 5. Why? Because 7 minus 2 is 5, right? And so I can do the same thing here. I look at the x value of that point, the ending point, pi, minus the x value of this point right here, which is just 0. Okay, pi minus 0 is pi. And so that's omega. And so what I can do now is use this formula and say, okay, 2 pi over pi. So my frequency is 2. And that number will go right here. So having this, I think, is really nice, but also, of course, knowing how to find that, super helpful. Because now that I've got all of my pieces, now I can just kind of say, all right, I'm going to come over here and just write it as simply as I can. Y equals 2 sine of, and since I'm doing theta minus 0, I can just call it 2 theta plus 1. So my strategy for how to do this is always, okay, can I find the middle? Because I need that, obviously, to find D, but especially for sine, I want to make sure that I can find that point that hits that midline and then goes up. Okay. From there, I should be able to find the amplitude. I just count boxes up and down. I've already gotten the midline. That's great. If I found the starting point, there's C over B. So the only real work that it really takes is finding B, which is that 2 pi over omega. So I have to be able to find omega. I got to be able to find the period, which is just like, and that's why I traced one full cycle. Kind of made that my focus, because if there is a frequency that's bigger than 1, you're going to see a bunch of cycles work its way through. Okay. Now the only thing that I do differently for cosine is I just pick a different starting spot. Everything else is the same. I already found B, it's going to be the same. I know A, I know D, all that stuff is all the same. The only thing that I now have to think about when I'm graphing finding a cosine equation is picking a different starting point. All right, sine starts at the middle and goes up. Cosine starts at a maximum. Right, and the regular cosine graph, you can see that that's exactly what it looks like. And so instead of picking this point to start at, I just pick a maximum somewhere near the origin. Now, it doesn't matter. Like I can pick this one, or this one, or this one, or this one. They're all good, right? I just usually pick the one that's closest. That means I'm making the smallest change possible, and that's never a bad thing, right? So if I pick this point right here, all I really care about is the x value at that spot, because that will be my C over B. Okay, but A is the same, B is the same, D is the same. So now I've got this pi over 4. All right, so there's pi over 4 right there. That's going to be C over B. So my new equation for cosine, y equals 2 cosine of 2, but now my C over B isn't 0 anymore, so I've got this theta. I'll just change colors, I guess, so you can see it. I'll go red. Minus pi over 4. Close parentheses twice. A is the same, B is the same, D is the same, but because C over B changed, I just have to make that change, and then I just write cosine instead of sine. How's that?
Thank you.
Yeah, good?
That's good.
Okay, cool. So yeah. There are 3 graphs that I drew on the review. So really there's 6 equations you're going to come up with, because you're going to do one for sine and one for cosine for each one. And that's how I do it. I find the middle. I always kind of start with sine as the one that I'm finding first. If I'm given the choice to find one or the other, sometimes they'll make us like, okay, find a cosine equation for this, or find a sine equation for this. But if they ask us to do both, I always kind of start with sine, because if I can find the middle, then I can find my starting point. Probably one of the harder things we do is that right there. Yeah. Cool. What else? Do you want another one, or do you want to just try the ones that are on the practice?
I think the ones on the practice.
Cool. Try those. I'll put up some answers. Now there's going to be a bunch of possibilities, so I'll just write them all down, because you could pick a bunch of potential starting points, and if you get one of them, then you know you've got it. And so I'll accept any of those answers as being correct for sure. Okay. What else?
Could you?
Thank you. Bye.
Could you possibly go over the domain and range for the inverse trig functions?
Yes, absolutely. Okay. So I can't graph the inverse trig functions on this graph, but I can get us started by graphing the regular trig functions here to kind of use that as a guide. And so I'll start with sine. I don't know, we'll go up to 1, I guess, up here. So here's regular sine of theta, which I'm going to call sine of x, I guess, for now, because when we switch x and y, I can't call it inverse sine of theta because theta isn't going in, theta is coming out, right? Because we're doing the opposite. And so when I think about trying to create the inverse, right? We switch x and y, we solve for y. And so if I do that, and so here's kind of like the actual, x equals sine of y. Well, the only way to isolate y right now is to break it out from the sine, and so I need to do inverse on both sides. So I'm going to take the inverse sine of x and the inverse sine of the sine of y. We'll get that by itself, so that's good. But in order to write this as best I can, that inverse notation, although we recognize it and we're smart and we're good, it's a little ambiguous because exponents of -1 kind of have 2 meanings. You know, one of them is inverse, but one of them also means reciprocal. And we don't want to get into the habit. And you're going to see in calculus, we don't want to use that symbol to mean inverse. We only want it to mean reciprocal, because a lot of the calculus stuff that we do, we start to mess with exponents. We're going to add, we're going to take an exponent, we're going to add a number to it, we're going to subtract a number from it, and when we get into the negatives, we want to just think reciprocals. And so they changed the notation to help us out. And so instead of saying inverse sine, we just call it arc sine, which makes a lot of sense based on the fact that a radian is really the measure of the length. Like, imagine on the unit circle, right? When I open up an angle this way, right? What I'm doing to figure out that theta is I'm just kind of tracking that point that's moving along the circle. It's moving along the arc of a circle, and that's what a radian really is. It's kind of like let's measure the distance of that point moving along the circle. And so there's that new notation: arc sine, arc cosine, and arc tangent. But what I would love is what's boxed in right there. I want that to be a function if I can. I want it to pass the vertical line test. If you give me an x value in that equation, I want to just give you one y value back. And the problem that we have with that is that, remember, so x and y switch when we talk about inverses. And so when I take all of these points and I switch x and y to find the inverse points, the problem that we have is that there are a lot of repetition. That's not a perfectly straight line, but there's a lot of repetition in the y values, right? This is the function. It's going to pass the vertical line test, no problem. You give me a theta, I'm going to give you the, in this case, sine, I'm going to give you the y value from the unit circle that comes back, right? But those y values repeat because we just go around and around and around and around. And so the problem that we have with finding the inverse of a graph like sine, and of course a graph like cosine, so this kind of doubles down for cosine, is that these functions are not one-to-one. And remember, one-to-one means for every x there's one y, and for every y there's only one x, right? And that's obviously not true. Take a y like, if this line was actually straight and flat, you've got all of these y values and infinitely more than that keep repeating. And so what we try to do to focus ourselves in here on just looking at a function is that we have to kind of restrict our periodic nature of these sine and cosine waves because they repeat. We have to kind of limit the space in which we look at sine, so that when we take the inverse, when we switch x and y, then we've got a function. Does that make sense so far? Okay, so what I'm going to do, I don't know how far back I need to go to do this, but I'm going to go like that, I guess. what I'm going to do, I'm going to start fresh again. What I'm going to do is I'm going to focus myself on just one small section of this infinitely long graph by restricting the domain to a section that is one-to-one. From here to here. Because there are no repeated y values. But the moment I take a turn here, now I'm not one-to-one. The moment I take a turn here, now I'm not one-to-one. And so what I look at for sine, y equals sine of x, is when I restrict the new domain, so this is just in order for me to get to an inverse trig function. I'm going to restrict my domain to just being from negative pi over 2 to pi over 2. Because that covers the whole range. That's already still negative 1 to 1, right? Your range for sine is 1 to 1. Negative 1 to 1, right? And so by picking this domain, now I've got a range that's good because it covers everything. I'm not limiting my range at all for regular sine of x. I'm just shrinking the domain down to give me that one-to-one feeling, because now when I do make this switch and I go, okay, y equals arc sine of x, the domain and range switch. Why? Because x and y switch. Shush. Okay. Because now when I think about the domain and range of arc sine, it should just be the opposite. From negative 1 to 1 and from negative pi over 2, writing in black is not doing me any favors. Pi over 2, pi over 2. That's terrible, but you can see it sort of. I should be able to now graph a function that looks like that. And all I'll do is I'll just switch x and y, right? Because that's all inverse graphs are. Take x and y. I mean, I don't know if you did it in algebra 1, certainly algebra 2. I know we did them by hand. Like we would take like a table of values for a parabola. Here's an x value, here are the y values, and we would just switch them, right? We would flip-flop them, and we would graph them, and we would get this sideways-looking parabola, or we'd do it with a cubic, or we would do it with whatever. It works with inverse trig stuff, too. And so now when I try to actually graph that, obviously there's an infinite number of points that exist in this space, but really the most important ones are the beginning. It's supposed to be green. The beginning, the end, and the middle, right? Now, yeah, at negative pi over 4, comma, negative radical 2 over 2, sure, I could switch those, right? Same thing here at pi over 4, positive radical 2 over 2. I could switch that, and I could do the pi over 3s and the pi over 6s. I could do all those spots along the unit circle. But if I just do those three kind of critical points, well, at least give me a beginning, a middle, and an end for me to try to graph this. And so when I do that graphing, and I'm gonna share my screen so you can see me do it on Desmos. It's a lot easier than me trying to graph it by hand because I don't have inverse trig graphs. Like inverse trig graph paper, it's not something that's very common. I'll just make it. I'll just create it, right? So if I go to Desmos, this graph settings over here, right? Normally, for like a regular trig graph, it would look like this, right? I would have graphs. Okay, y equals sine of x. Yay, there it is. But I need to now switch like my scales too, right? So here's kind of the section that I'm looking in from here to here. Right, there's a really good section of this graph, but I need to switch some stuff. I need to change I'll go pi over 4 just so you can see it. Like obviously this graph didn't change. Like there's still, the section that I'm looking at. I just want to do the opposite. And so really all that happens is I switch x and y. All of my points just switch. So this point that was right here is now right here, right? You can see x and y have just switched. 0, 0, still 0, 0. But this point that was pi over 2 comma 1 is now 1 comma pi over 2. And just like any graph of a function and its inverse, it's a reflection over the line y equals x. And so this graph is the only real section, and it doesn't have to be perfect. We don't really graph these by hand very often. But like right there, there's the 0.707 comma, negative 0.707 comma negative pi over 4. That's just the opposite of the other one. Same thing over here. But really just these 3 points, I think, are the 3 most important ones that are there. Okay, being reflected over that line from this graph right here. But in order for us to see the graph, obviously we just needed to restrict the space that we were looking at. That was a lot of words. Did that make any sense?
Yeah, that makes sense.
And then when I do it for cosine, I do the exact same thing. I just have to pick a different section of space to chop this this function that repeats, so that it's just 1 to 1, right? And there's a lot of spaces that I could choose, and that's true for sine as well. As long as I pick a space, I'm good to go. We've just kind of mathematically, we've kind of chosen one section so that we're all kind of doing the same thing. For sine, it was negative pi over 2 to pi over 2 because that worked. For cosine, the section that we've chosen is from 0 to pi, right? This space right here works really well. Could we have gone negative pi to 0? Sure, right? This one works really well, though, because everything's positive, or at least 0, when it comes to the x values, which means when we switch x and y, now my y values will all be positive. And so you'll just see that when we get ourselves to that arc cosine, and I'll share my screen again so you can see it, we've just got 3 points, right? So this was 0, 1. So that will switch. Here's pi over 2, 0, right, on a regular cosine. And here's pi, negative 1. When I come down here, when I make the switch from sine to arc, sorry, from cosine. Those for a second. Cosine. There it is. Cool. Obviously, my scale is just going to work well for me when I get to the cosine. Arc cosine. Right there it is. Again, it's a little bit funkier to see because we're only reflecting like this section. It's weird, so I'm going to take that off. But it's still there. It's still true. It's just a little trickier to see that one. But like kind of looking from here, it's just so weird because of the way the scale is set up. But from here to here, right, that's kind of the section. These 3 points are the 3 points that I'm going to make the switch. So 0, 1 is now over here at 1, 0, right? 0 pi over 2 being the reflection over this part, right? So this point and this point, right, reflected over that. That point's shared, which is really nice, but that's not a super crucial point for us. This point and this point, right? You can see that kind of reflected over that line, and then this point way up here, and this point way down here, right? That one and this one being just switched, okay? And we have that same kind of smooth motion, right? The thing about your regular sine graphs is that when we near the top or near the bottom, that's kind of where we slow down, right, for a quick second, and then we'll kind of make our way back down. When we do the arc stuff, we go down kind of quickly and then start to flatten out and then head down, obviously because x and y are switching. Okay, so there's arc sine and arc cosine. Last one would be tangent. So for plain old tangent, I'm just going to look at one section. So I'm just going to pick this one between these 2 asymptotes because that should cover everything, right? Kind of going, back it up, sorry. All right, so there's one period of tangent. We'll go +1, -1. So we've got this point right here, this point right here, and that point right there. And because one period of tangent is 1-to-1, I don't have to do any restricting of the domain within that period. However, obviously we know like tangent is that, goes again and again and again and again and again. It's going to happen over here. It's going to go like that, right? You've got that same issue with, being 1-to-1 everywhere. No, because, pick a y value, it's going to repeat plenty of times, right? It's going to run into itself a whole bunch of times. But the nice part about tangent is we have the vertical asymptotes that break apart that repetitive nature. So if I just pick one period of tangent, namely this one, from -pi/2 to pi/2, 1, -1, 0, 1. If I just look in there, so if I'm looking at plain old tangent, I'll call it of x, right? My normal domain of, okay, I just can't be from -pi/2 and then pi/2 and then 3pi/2 and then 5pi/2 and 7pi/2. If I just look at one period, so I am kind of restricting the domain, but I'm just really looking at one section, which is nice. Now I can't include -pi/2. And I can't include pi/2 because there's an asymptote there, right? And then my range is all real numbers, -∞ to infinity. Now when I make the switch, well, my domain and range, of course, are gonna swap as well. So when I look at, let's switch colors here. When I look at arctangent, right? Now my domain is all real numbers. And my range, I keep running out of space. My range is now my old domain from well, that's big, pi/2 to pi/2. Again, I can't include those endpoints. If I couldn't include it in the domain, I certainly can't include it in the range. And what you're going to see is that these 3 points and these two asymptotes, the x's and the y's are just going to switch. And so, one last time, let me show you the graphs on Desmos. Okay, so plain old tangent of x, there it is, over and over and over again. But I'll get rid of that for now. Look at arctangent. Okay, oops. Right, so there's -1, -pi/4, right? So that's this one right here switched, okay? 0, 0, and then +1, pi/4. So perfect, there it is, nice, right? But we also have what used to be vertical asymptotes at x equals whatever. Well, now they're horizontal asymptotes at -pi/2. And you can see that this graph gets trapped in between those, okay? And so what I tried to do, I think, let me see if on the review, where did I put it? Maybe I put it on the wrap up. I tried to put it somewhere. I thought I did. Inverse trig. Yes, there we go. I added this actually recently, last night. I added the 3 crucial points that we need. Okay, that one, these, and those. And of course, for arctangent, I also included the horizontal asymptotes. So that if we were asked to graph these by hand, which doesn't happen very often, but it can happen, right? We really just know the couple things that we need to be able to do that. I'm more concerned, I think, with knowing domain and range for each, so we know what kind of numbers we're allowed to plug in and what kind of numbers we're going to get back. But if I tried to ask you for the arc sine of 1, that you're not giving me an answer that's outside of the domain. Or sorry, that's outside of the range, you know what I mean? Like we want to just trap ourselves within like 1/2 of the circle, right? From negative pi over 2 to pi over 2. We're just over here, right? We're just looking, hopefully I'm in the right side, maybe I'm over here. From negative pi over 2 to pi over 2, and I just want to be from here to here because that covers all the y values I would need. Same thing for cosine. I'm just going to go from 0 to pi because that covers all the x values that I need. And so we're not getting answers outside of that when we plug stuff in the calculator. Like, why am I not getting 7 pi as an answer? Well, because that's not the space that we're working in, right? We're working just between negative pi over 2 and pi over 2, or between 0 and pi for cosine.
Thank you so much.
Is that better?
Yes, that makes a lot more sense now.
Okay, good. I know I went through it quickly, so I was hoping some people would stick around for that. But I also tried to make the write-up that I did for each of those sections kind of stand. Updating. Okay, good thing we're done. Hopefully making them kind of stand alone too, so that if you do run into some questions, you can look at those notes and it might help you a little bit. Cool. Megan, anything?
Thank you so much. I'm
You're welcome. Yeah.
Bye.
See ya.
No, those were the 2 things that I had questions on.
Perfect.
So.
And those are the 2 things that I expected people to have questions on. Like, how do I come up with the equation from a graph? And what is the deal with these inverse trig? Again, not super crucial to your success in Calc A for sure. We get to sine, cosine, and tangent a little bit. And we'll get to secant, cosecant, stuff like that. But we certainly won't touch anything that has to do with inverse trig in Calc A, but like Calc BC, we might get there, right? And just having even just a couple days of background. Okay, I'll get to the calculus part, and maybe I don't know everything about them, but I've got a little bit of memory from last spring with Rosie, and maybe he's told me some things that, oh yeah, I kind of remember that. Oh yeah, we had to limit the domain in order to make it work or whatever, right? That's going to come into play once you get a little further into it. But inverse trig, definitely not the most important thing. Being able to deal with, I think, sinusoids is probably more important in applications of the calculus that we do. And we won't even get to that, really. I just got to give you the basics. Cool. Anything else I can give you? Otherwise, we're good to go.
Okay. I think we're good.
All right. Stop by tomorrow so we can just confirm registration stuff. And if there are any other questions that come up as you actually work through the review, I can answer those for you tomorrow, and then we'll test on Thursday.
Okay.
Cool. Thanks, Megan.
Thank you.